What's up guys, Shawnthebro here, and today we are back for some more of the blueprint only input buffer system. So I'm doing this in my third person tutorial series. For those of you that have seen the first two episodes, you'll know that it's not required that you watch that series to understand what's going on here. I'm just laying out everything for this blueprint only input buffer system in these specific episodes. I'm just using this as an example so that you can see some things going on here. So in the first episode of this, we set up the initial system where we could press inputs and keys on a keyboard and they would actually perform an action. In the second episode, we set it to where we could bind certain inputs to certain input types or command types, so that when we pressed inputs such as, S, that was like a down input, not the key S, but anytime the down input was pressed, we would queue that up and check against commands. So this makes it where we can use controller, keyboard, or other types of inputs and still have them checked against the command list. In today's episode, we're going to go over input axes because we had things like forward. You can see it's printing now. I know there's a lot of text at the top, so it's kind of being hidden. But if I keep pressing this, you can see E_forward is printing, and then E_backward. In the previous episodes, we had only set up input actions. But we also need to set up input axes. So input axes are any inputs or buttons that have a value that has to be tracked, not just pressed and released, but it has to track how much of it is pressed, how much of it is being held. So in the case of a joystick, you might have it halfway up. That would be 0.5 if it's on a scale from 0 to 1. Down might be -1, that sort of thing. So we're going to cover input axes today. And once we do, we'll be able to perform other commands with them. So in this case, I don't have an animation or anything that actually triggers when I do this. If I am to do this command that we set up at the end of last episode that did not work, like up, down, punch, you can see I triggered command 2. Now, command 2, right now, it's just triggering that animation for the punch because I don't have a separate animation set up in the NMBP. But you can see it printed, and it's printing from the start command function that we set up with the command that was actually triggered, so when the inputs were found in it. Okay, so that's what we're doing. We're going to be setting up input axes today so we can use them in our input buffer. This is super important because we're going to need these for charge and held attacks potentially, and we're going to need them just in case we want to do certain actions bound together, such as we want to be holding this direction and then press this button, almost like a running punch or something to that effect. And that's all depending on how you set up your system. So this is one method of going about it. For those of you that have watched my fighting game tutorial series, you'll notice that the input buffer is slightly different, although very similar. Just depends on your game and your preferences. Anyway, with that said, we're going to go ahead and get started. If you'd like to get caught up on the blueprint only input buffer system that we've set up in this little mini series here, you can go ahead and click this icon in the top right corner. It'll bring you to the very first one. So that way you'll be able to see everything we've done to get to this point in the blueprint only input buffer system. Alternatively, you can click this iCard right here, which will lead you to the playlist for the third person tutorial series if you do want to get caught up on everything that we've done to make this game look the way it does now. It's not required for this episode. Alright, and so now we can go ahead and get started. Since this is blueprint only, we're not going to be using C++ or code today, so we're actually specifically going to go into our base character BP and continue working in there. We have a lot of logic set up for other tutorials and things like that. Like I mentioned before, don't worry about that. The only thing we have to care about are the things I'm going to point out in this episode. So I'm going to show you all the events that are related to the logic we have. I'm going to show you what's changed in other events that we used in previous episodes and new events that we're adding today. So the very first thing I want to do is go into the event graph. There is something that we should fix up before we go any farther. It didn't really matter when we were using input actions, but there's a common bug if you're trying to iterate through a loop and you remove elements from it, which is what we were doing. And you'll see this as you get more complex inputs. This will become more and more of an issue. So I think we're going to fix this up right now so we don't have to worry about it anymore. In our event, add input to buffer. Okay, this is an input action. We can find it in our project settings that we set up, and it will track any single key that is pressed. So we have add input to buffer, and it is any key. So anytime any key is pressed, then we're going to get the key that was pressed, and we're going to be able to do logic with it, plain and simple. Well, what we need to do is make sure that instead of removing old elements from the input buffer, we were checking before, and if they are below 0.2 seconds old, then we're removing them from the input buffer. And that's fine, that's all well and good. We want to either remove inputs or ignore inputs after a certain point. However, we don't want to remove them while we're iterating through the loop, which is what we're doing before. So this is what we were doing before, okay? This remove here after this true branch. None of this has changed. This is all the same. But I'm going to do something else here as opposed to this remove node. Okay, so remove the remove node. There we go. And we're going to put this in instead. Okay, I'm going to clean this up for you. That way it's not super ugly. Something like that. Okay. And so what's going on here is we're going to track all the inputs that we want to remove, and then we're going to remove them once the loop has completed. Long story short, when you're iterating through a loop, it's grabbing each index that it's got to go through, and it's going and looping through it, doing the logic that we choose in the loop body. If we remove an element while it's going through the loop body, then the indices in the array change. Okay, so say you have 1, 2, and 3 in this array. We remove 2. Well, now 3 moves up a slot because we have 1 and 3. So visually, if we do this, good paint example real quick. Say we have 1, 2, and 3, and this is index 0, 1, and 2. Okay, if we take out 2, then this moves up into that spot. So 3 moves up into 2 spot. Well, that means we don't have an index 2 anymore. Instead, we only have 1 and 3, which is index 0 and 1. So the new array looks like this: 1, 3, at index 0 and 1. So if you're looping through and you're removing an element at the same time, you can get this case where you end up skipping elements or going over elements twice. And we don't want to do that. So we don't want to remove it during the loop. So instead, I'm going to make a new array called inputs to add, and I'm going to remove each index every time. Then we're going to clear this array afterward. That way it is empty every time. When we go to remove these elements, we start fresh. Okay? So the first thing we need to do is we need to basically make another array like our input buffer. And I've called it inputs to remove. So you can actually duplicate this. You don't need to worry about that eyeball that you saw. This is so I can visualize it in the editor. I'm going to disable that because we don't need it right now. And so you can take this input buffer and either copy it, duplicate it, and get a new one here and call it inputs to remove. Or you can just make a new variable, change the type to our f_input_info that we made in this mini series, and make it an array by clicking the little pill sign here and changing it to array. So single to array. All right, we're not going to put anything in it by default. The only time we add to it is right here where we were previously removing our inputs. We just want to add elements to it. Okay, once this loop is completed and we have looped through the entire input buffer, we then want to execute the logic to remove the inputs from the input buffer array. So here's how we're going to do this. We're going to loop through our inputs to remove array. All right. We want to do this one specifically because we don't want to remove elements from the input buffer while we're looping through it. We're going to do a for each loop on it. All right. We're going to drag off of this and type find. And we want to make sure we choose the array find item. Okay. Now we're trying to find it in our actual input buffer array because we want to know if we can remove it from the input buffer. So we're looping through the inputs to remove, but we're finding it in the input buffer array. Then, using the input buffer array, we're going to do something called remove index, which is going to remove that index from the array. So we pass it an index, and it'll just remove the element at that index. Well, the find node returns an index where it finds this value. So that's the index that we want to remove. We just pass it in from find straight to remove index and pass that through on loop body. Okay, so you can see that's what I've done here. This was all added in extra. And now on completion of this loop, we should also clear this array, this inputs to remove array. All right, so right here, I would just drag inputs to remove, clear, and I'll empty it out. At the end of that loop, we no longer need it, and that'll keep it nice and efficient. Now, the rest of this stuff we actually have had in here. So this is where we check the input type map. We add the time that this input was entered, and then we call add input to input buffer. Okay. Now, since it has been a while since the previous episode, I'm going to just show you add to input map is the same. That's the other event that's here in the event graph. Haven't changed anything with it. Now let's go up into setup input actions. Now setup input actions is what we did in the previous episodes where we bound the keys to enums. Okay, so we bound the actual input actions and buttons to enums. That way you can use it for more than just the specific, one singular button. A good example of this is if I go into project settings one more time and we look at our inputs. So I have attack 1 here is the 1 key on the keyboard, but I could make it as many buttons as I want. As I add buttons to these, or different inputs to these, when it finds the input name of jump or attack 1 or special action 1, whatever it is that we're calling them, then we're going to bind them to enums that we set up in previous episodes. I'm not going to go over all that again, but just remember that's how this was working. The only change I had to make in here, which you probably won't have to make, is I changed the name of punch to attack 1 in the third person tutorial series. So just be aware of that. If you did change the name like I did, make sure they match. This is no longer punch. So I had to change it from punch to attack, otherwise it wouldn't find that input. Okay? So make sure you have attack 1 in here if you're doing what I'm doing and have attack 1 as the substring. That's the only change you might have to make, and is very, very specific. But the important part about this function is after this sets up all the input actions and it gets completed, we made this function called setup input axes, but we never set it up. We created it and we never filled it out, so it wasn't doing anything. And that's because we didn't have input axis support yet. That's what we're going to do today. If you didn't make this function, you can go ahead and do so now. Just make a new function, call it setup input axes, or something that you'll know is similar. Call it on the completed of the first loop in setup input actions, and then we can go into that function. This function is going to be pretty similar to setup input actions, and you can already notice some similarities when I switch between the tabs, but it is going to be different, and it's different enough specifically where we have to actually check the input values. But you can feel free to copy some stuff if you'd like to save some time. I'm going to still go over everything in this episode. So the first thing we need to do is we need to get our axis names. To do that, we can get our input settings and get axis names. Okay? And this is going to return our input axes. Right here. These are action mappings. Okay, these are axis mappings. It's going to get the names of all of these. So we have move forward, move right, turn, look up, right, look up. Right now, we really only care about move forward and move right for this specific episode, but you can set up as many as you'd like. Okay? And now, we have an array of them, so we're going to loop through them. I'll continue with my example down below here. We're going to loop through the axis names. Then using the array element that comes out of this loop, we're going to get the axis mapping by name. Get axis mapping by name is a function from get input settings. or really just the input settings type. So we can type get axis mapping by name. Okay, I'm not going to clean it up too much since you can see it right above, but you're just going to pass in the array element here. And so once it finds the axis mapping with that name, it's going to return the actual mappings to that. And what that means is it's going to return the actual individual keys. So in the case of move forward, I have WS up, down, gamepad left thumbstick Y axis. For move right, I have AD gamepad left thumbstick X axis. So it's going to return all these keys for that mapping, okay? We're going to loop through those keys because we have to bind them to that enum. So we do a for each off that, then we take the array element and we break. And you should get break input axis key mapping. That's going to give you all the data about these input axis keys. It'll have a name, a scale, and a key, just like this. Now the name we're going to use to track what it was that we pressed, forward, right, whatever. The scale is different from the input actions because this is how much the axis is pressed. Remember, like I said, it could be halfway held down or halfway pressed in a certain direction. Or it could be full, 1, -1. Then here's the actual individual key, which we were getting the display name for. So we could pass it into the add to input map function, which is something we set up again in a previous episode. Okay, so long story short, we need to check and see if the axis name is our predetermined name, so we know move forward, move right are the ones we're trying to capture today. To do this, it's pretty simple. You can do a contains on a string and pass in the axis name and the search in. So we're searching the axis name for this substring, which we want to be move forward. You don't have to use case or search from end here unless you want to. All right. Once you do this, you get a Boolean result, which we have to pass into a branch. Now, for the setup input actions, I'm going to that function now. Notice how we have the same sort of logic with a Boolean result. If it's true, we add the input map. If it's false, we go to the next one. Sure, that's all well and good, but there is something that we're going to need to add here, okay? Something that's a little bit different here. So we need to not only go to different values based on if this is true or false, if funds move forward or not, but we need to check the scale as well. Because if we have move forward, you'll notice I don't have a move backward or move left. I have move forward, move right. Now, things like S and down have a -1 scale, so that's essentially the moving backward. Same with moving right. D is to the right, it's moving to the right. But A is -1, it's moving to the left. Okay, so if move forward is found, true, great, but we're not done yet, like in the input actions. For this, what we have to do is we have to grab our scale that we have here, and we have to check if it's greater than 0 or less than 0. Technically, you could check if it's 0 as well. However, I don't see the need to ever put a scale of 0 for any of these cases. Because these are, when you press this input, this is the value you're going to get if you press it fully. So if I press W all the way down, I'm getting a scale of 1. Okay, so you don't really have to check for that edge case of 0, but you could if you'd like. Main things are, you have to check if it's greater than 0, we know we are moving forward. If it's less than 0, we're going to be moving backward. Okay? So, once more, if move forward is the command or the axis mapping that we're on, and the value of the scale of it is greater than 1, we're on an input, a key mapping, that relates to moving forward. So branch, true, is add to input map. Again, a function we set up in a prior episode, but it looks like this. So if we have add to input map, okay, looks like that. And then what we have to do is pass in the input, comes from key, get display name, Here's the input. And then you choose the type, and this is a move forward. Now, the other case with this is if this is false. If it's not greater than 0, then we're going to go to another branch, and we're going to make sure it's less than 0. Again, it's being a little specific. You could just see if this is false, you don't have to necessarily go to another branch and check if it's less than 0. But just in case you have that weird edge case where 1 is 0, I brought if the scale is less than 0 into another branch, and if that's true, I add the input map with the input, and I give it a type backward. So forward and backward. Now from here, you can pretty much copy and paste this logic, all this stuff, because we're going to be doing the same for right and left. Okay. So you'll notice if move forward is not the input access we're on, false, we go into another branch, and it's the same sort of check, but we're checking for move right instead. So if the name of this axis is move right, we go into a branch. If that's true, then we check and see if the value is greater than 0. If it is, we're setting E right as the type. If the value is less than 0, if it is, we're going to go into a branch and add the type of left. So now we've successfully bound forward, backward, right, left input axes. We don't have to do anything on completed on either of these right now. We could add some stuff in the future, but we'll get into that in the next episode. All right. Now with that, we can go to our other functions and just make sure everything's looking good. So add input to input buffer. In this one, we can print out any values that are being added to the input buffer. I'd recommend doing this if you're not already. It's very simple to actually do. So all this logic has not changed, but I wanted to see what values were being pressed, and you'll see when I play the game, you see that it's saying forward, backward, left, right, and my other ones, attack, special move, special move. Well, add input to input buffer has an input info that gets passed into it. Remember, we called this from the event graph. Okay. And this input info can be broken. Break, f input info. And off of that, we have input name and timestamp. If you take the name and just convert it to a string, enum to string, then you can use it on a print string to print this value to the window. Otherwise, if I don't do this, then nothing's popping up when I press individual keys, and that's all well and good. That's what you'll want in the end. But while you're testing, it's a good idea to have that in so you can see what values are being added. All right. Now, we can also go to our check input buffer for command that's called here. I don't change anything here, but again, just to give you a nice overview of what it looks like. Has been a while, so I'm just skimming it very quickly because you probably have all this. But if you ran into any trouble, you can go ahead and look at what I've got. If you set it up exactly like this, it'll work without any issues. So you can pause the video and look around and modify if there are any problems. Okay, and then we can also go to start command. Start command is what happens if check input buffer for command finds that a match was made between your commands on your character and the values in your input buffer. So if we go into start command, here's what start command looks like. Again, you can verify, make sure all is good. I have not changed anything with this, but you can look at the print string here, and that's when the value of the command that fires gets printed. So if I am to do like that, I get command 2, like this, command 1, and I technically have a command 3, but it's very difficult to perform right now, and I'll explain that in a second. We're going to get into creating the actual commands here. So now our logic for the blueprint-only input buffer is actually solid. That's everything we had to do to update and add input access support. But we have to make sure we have values we can test with. So if you go to your class defaults on your character, your command list, you'll have at least one command, because this we set up in the first episode, then we modified it to use the types as opposed to the inputs. I had a second command that I was using, but it didn't function because we didn't have input access support. If you don't have this, go ahead and make it. Make sure that your input axes work. So I called it command 2. I have forward, backward, attack. Now I have another one that I made as well. You can add them with this little plus sign right here. I've called it command 3, and I made it right, left attack. This one is very difficult to perform. There's actually a bug in the system right now because of the way we have done our logic. Nothing necessarily wrong with the way we set up our input buffer, but more so the fact that we're not making this circular and we're removing elements that can cause a bit of an issue. And so some inputs, especially as you add more and more commands to this array, are going to get harder to perform to the point where you have less and less time to perform them every time. This is something we're going to fix in the next episode. However, we need to have these input axes working beforehand, and I wanted to show you the fix with the inputs to remove instead of removing the index while looping through the array. With those two things in, the next thing we have to do to set up our input buffer is going to be a piece of cake. And it'll be pretty fun. And then at that point, you'll have a fully functional input buffer that is reliable. We'll have to convert things to frames instead of seconds if you're interested in that. And then we'll have to add multi-button, holds, and charges. Okay. So there you go, guys. I think that's everything we need to show off for today's episode of the Blueprint only input buffer system. But the rest is coming. So hopefully this helps you use your commands and set up a Blueprint only input buffer system. You can use this in the fighting game. You can use it in your own projects, or really with any of my projects as well. It will work. You just have to make sure that you're going to set up commands in your characters that you're going to use and test them out every step of the way. Make sure everything's working as much as it can. And then as we continue going along, I'll iron out any bugs in the Blueprint only version. And there you go. So guys, if this helps you, please subscribe. It does more for myself and the channel than anything else you can do, and I really appreciate it. I want to give a huge shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys for everything you do. I really, really am grateful. I really appreciate it. I'm so incredibly excited about continuing to show you content week after week. Thank you so much for everything you've done and all the love and support. If you had any issues with this tutorial or any of the tutorials I have, feel free to join the Discord community. It's completely free. I'd be happy to help you out and assist with any issues. We'll get you sorted and back on the right track. Anyway, guys, like I said, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.